So you will have one question that requires the long derivative method, the limit. Remember, I told you have to do it once. The rest, you don't. So let me write down this question.
I had trouble with this problem. I kept on wanting to go back to the easy way. Oh, was I supposed to be doing that this entire time?
You
Yeah.
have to do it at least once.
I didn't do it either.
Well, now it's time to do it.
It says use the rules.
Now, you can check your work with the rules, but
Check my work with the little green check mark. If it comes up with a red X, I say, oh shit.
okay.
You have fun in your math class stuff. You always seem to be having a good time.
Yeah, I think so. You guys are fun. Okay. That look okay? So use the derivative rule. So when we first did this, I said do it in steps. That way you won't mess it up. So first step, I'm gonna write you a note here. Find the x plus h. So that'll be x plus h over x plus h plus 5. Step 2, find the numerator, this top part. So take this result and subtract the original. So that will be this nonsense minus the original. So there's step 2 set up. All right. Now we have to add fractions. Life sucks. Oh well. So LCD, I'll make a note here, is going to be the product of these two. So this one will need the x plus 5. This will need the x plus h plus 5. Well, you don't have to put parentheses, but you can. So we'll multiply that out, subtract the fractions. So this distribution will be this on top. On the bottom, I will not multiply because maybe something will cancel later. I don't know. Plus there's 3 terms and 2 terms, and it just looks annoying anyway. It's all about working less. What's that? Yeah, there is so much, so try our best to reduce it, not make more. We got enough already. At this point, combine the fractions, right? This garbage minus this garbage. Distribute your negatives, start canceling, and you should get a bunch of stuff to cancel out, right? Notice how x squares will cancel, right? Xh will cancel, 5x will cancel. Can we skip that step, or do you not see? Do you see it? It's going to cancel. You want to see the cancellation?
Yeah.
Okay. See how the x's are gone, xh is gone, 5x is gone. So the result will be 5h over the LCD. So there's step 2, the difference piece. It's this. I don't have space for step 3, so we'll have to do it on the next page. Step 3 is divided by h. That's that final part.
So what canceled on top would be dependent on if we actually like pull it out the bottom.
Well, I mean, the h is not going to cancel. There's no way. It will cancel with the next step, though. If we would have been left with like a x plus 5 on top or something, maybe that would cancel this one.
Or is it because I'm just being stupid and you have positive x squared and negative x squared?
Oh, is that what you're asking? How it canceled?
Yeah.
Yeah, that's why.
I researched it.
It's okay. It's late.
Oh, that's something to do with.
So that is the final answer here. There's nothing more there.
No, that's as pretty as gonna get. As polished,
Oh, my goodness.
polished can. Polished turd can be.
Oh, I get it.
I remember watching that on MythBusters. They polished a turd. Came out quite beautiful.
I mean, there are fossilized.
That
True.
people display on their mammals.
It's true.
I mean, it wasn't fossilized, but they managed to harden it. I guess I don't remember how they did it though. I think the dinosaur poop might be cooler though. Okay, but you guys good on step 2?
Yes.
So step 3 is divide by h. So this top part is this. So step 3. No. That was step 2. So we had, what was it, Nick? Positive h showing on top? 5h. So that will be 5h over x plus 5 plus h times. I think it was plus h plus 5, right? How I had it. Yeah. Consistency. It doesn't matter, but consistency is important to some people. So divide by h, what I'm going to do is instead multiply by 1 over h. You agree that that's the same, right? So doing it this way saves you some steps. Dividing is the same as multiplying by a reciprocal. So that cancels this h. We are done. This is the, well, this is the difference quotient. We still got to take that limit, I guess. So, step 4, the easy part. The limit of all of this garbage will equal to the limit of this guy which will give me 5 over x plus 5, x plus 5. Which will be this. So that is the limit, that is the derivative using the limit process. Any steps that makes sense? Mhm.
Where did that H go?
Which one?
It suddenly became,
Oh, this,
yeah, 5.
take the limit.
Oh, with H is 0. Oh, I'm sorry, I missed it. Thank you.
Yeah, so once you stop writing it, that means I took the limit. So right here, h was 0. Let's go over one more time together. So the first step, plug in x plus h into the original function. That's this. Second step, subtract by the original g. So that was this. So that step was pretty easy, but this requires us to do fractions. That's the annoying part. All of this is subtracting fractions. But that's the difference of this here, which is the top part. Then we divide by h and then take the limit.
Where did you get the, maybe I missed that part. No, step 1?
Step 1. This is given to us. And this is what we're using. What's your question?
So it never actually says what H is supposed to be by itself. So am I missing something or?
What,
Will it
the,
be 0?
the h is going to go to 0 at some point. That's what h is doing.
So where do we get the x plus h plus 5 from?
So x plus h goes inside this x. So this x right here is replaced by this. See what I mean? It goes in the x. So it's not, so I don't really write parentheses, but it's understood that this is this. Any other questions on step? Any of the steps? Once you finish with that, you divide by h. Once the h is canceled, you take the limit. That's it.
Could have had that h, that divide by h all the way through, you just left it out. So that would be
The piece by piece. You can do all at once if you want, but I do this just so you won't mess it up. You can see all the details.
Was that doing the derivative without the rule?
What's that?
Was that also doing the derivative without the rules?
If you did derivative without the limit that you're asking,
No, the rules,
yeah, this is without using any of the special rules. This is the limit. So no, if they had asked us to do derivative using the other rules, this would be a quotient. So if you did quotient on this, you're gonna end up with this. So that's the first one. Number 2, find the slope of the curve at the indicated point. So all you want to know is the slope of the tangent. So I'm gonna skip that one and do 3 because 3 is more involved and that's part of the question. Find an equation for the tangent line on the curve at the given point. So the curve is x squared plus 3. The point they're asking about is 490.
Wait, are you looking at 3 or 2?
3. I messed up.
It's not doing it.
2 is an easier version of 3. So we're gonna do the hard. Okay, so to find the equation, we need the derivative, we need the slope, and we need the point slope equation. Okay. What is the derivative?
Yours.
Yeah, it's 2x, right? Now, the M tangent, we need that. So M10 happens when you plug in the point x value. So the slope is 8, this is 8. To find the equation, you need this formula. So you plug in the point, plug in the slope. So use this. And the M10. Find the equation. This is my x1, y. Y minus 19 equal to 8 times x minus 4. Y minus 19 equals 8x minus 32. Add 19 over. Negative 32 plus 19. What is that? Negative 32.
Negative 13.
This is the tangent line to this graph at this location. That's gonna be right. Any questions on 3? Well, we did. I'd like to see a visual of this. What do you see? Let's do that. Or can you see 9?
I can see, but I just can't see what you're writing, like doing the
So
math.
when I switch to the camera, you can't see it.
Yeah, I can see now.
You see it now?
Thank you.
Oh yeah, I'm switching back and forth.
Okay,
Were you able to see it earlier?
no, but
Like
I
not-
can see it now.
Like not at all?
Yeah, not at all. I can see it at all before.
Well, that sucks. You're good now. Stick to sharing. Just let me know if you can't see the screen. Okay?
Thank you.
See the canvas page. Okay. Let's see. Or the same thing. It's a different function with a different point. So let's do 5. This one is something I don't think we've talked about. Let's do 5. So it's 5 points. Where the graph of the function have horizontal tangents. F is equal to x cubed minus 21x. All right, so back on the notepad. So we need the derivative. What is f prime?
Square. It's 21.
3x squared minus 21. Okay. Now, what does the horizontal tangent
That's a zero.
Okay, when we're talking about tangent lines, right? So for horizontal tangent means you have a line there's a point somewhere in the graph that's horizontal, like for example, sketch. Like if you had a graph. There would be you said that tangent lines look like that, right? There's some line, the slope tangent to the graph. Horizontal tangent. It's at peak or at valley. So the line are horizontal, which implies that the slope is zero. So you have to set the derivative equal to zero because that's what it does when this happens. Okay. So that's the meaning of the question. Say horizontal tangents are saying find the x value where the derivative is equal to zero. That's the another way to ask this. Basically, you take the derivative, set it to zero, and solve for x. This finds you the horizontal tangent. So factor of 3.
You said horizontal tangent is when x equals 0.
When the derivative is equal to 0. You set it to 0 and solve for x. So whatever x value you get, that value is the location that gives you horizontal tangent. Or makes the derivative 0 when you plug it in. Divide by 3 and solve for x. Root both sides. So x is equal to plus or minus square root 7. So there's two places on the graph that have horizontal tangents. So visually, come back to this one. Visually. You can see the graphing program, right?
Yes, I can.
Making sure. Now I'm parent recording now. So there is my horizontal tangent. So at those peaks, we have a line going this way. In other words, we have slopes of 0, which happens. Root is equal to 0. Those are often subject questions. Square root of 7 is 2.646. This x value is the location that we found. Okay. 0.6457. That's what we found.
About percent.
Find the points with graph and the function. Goes on tangents. Did the multiple choice have whiteouts?
Yes.
let's plug this nonsense in here. Find a line up. So f of square root 7. Square root 7 minus 21 square root 7 negative 14 f of negative square root 7 would give us positive 14. So our answer, the amount of space here, square root 7, comma, negative 14 square root 7, and negative square root 7, comma, 14 square root 7. Any questions about this problem? We find the x value like this, by setting the derivative equal to 0. Once you solve for x, plug that into the original to find a corresponding y. That's the only way to get the location that they had on the graph. Any questions on that? Okay, you guys good on time? Number 6, similar to 3 and 4, but they're giving you the slope, but not a point. So you have to use this information to find the x and y. Highlight number 5. You know how these horizontal tangent implied sequence, the slope is 0. Here, there's number 6 is straight up telling you that the slope is 2. So you're going to set the derivative equal to 2 instead. Do the same thing we did in 5. So, that makes sense.
Set the derivative of the equation.
Solve for that 6, or sorry, for that x on 6. let's do it anyway. We want the equation, not just the point. One equation of the tangent line. The tangent to the curve f equal to 2x squared minus 2x plus 1. First thing I need is the derivative. It's telling you that the curve, the tangent line has a slope of 2. So that's basically the n 10. So 4x minus 2 equals to 2 will help me solve for the x value that gives me a slope of 2. And when I plug that x value I'm going to find into f, I'll have the y value. Once you have the x and y, then you can find the slope equation. Solve for x step by step. Do I have the x value? X is 1. I need the y. X1, y1 in order to use the formula. Plug in the 1. My value is 1, 1, 1. X and y, 1, 1. So there's a note here. Find y. This gets better. Set at prime for 2 and solve for x. So again, x you found. Into f. So find y. So now we just find the equation by using this guy, like we did earlier. Plug in the m, plug in the x and y. Skip a couple of steps here. Just on the y. So use the point slope and x1y will n tangent to find the equation of the tangent. Any questions on 6?
So the one on number 5, we set it equal to 0 because our slope as the horizontal, the slope of a line, a horizontal line is 0. So on this one, we're setting it equal to 2 because they told us the slope was 2.
Yeah, straight up said it before they hinted.
So on the one with the 0, we plugged it into the derivative, but on this one, we're plugging it into the original. I don't know, how do we know when we're plugging it into the original?
No, we plug into the original to find y here. We set it equal to the derivative like before. Find the x.
Set the derivative.
So you say equal to the derivative to find the x. You plug that x into the original to find the y. But you gotta remember what the functions are doing. The original gives you location, so the derivative gives you slope. Location of the graph. Any other questions on number 6? This is the 10th question. So it looks like after that point, we're just doing the derivative rules. Different types of functions. Then towards the end, you get to implicit, and then some word problems. And at the very end will be inverse derivatives. So the rules, we'll do some of them. I mean, these are almost easy, less difficult ones. So let's do, which one would you like to do?
Something that looks terrible.
7, easy, right? No.
That was confusing.
Okay. Let's do 11 has a cosine again. 6x sine. It wants me to do second derivative. So yeah, that one sucks. You know.
I agree that like sounds too long.
Find second derivative. So they won't. You agree that this is a product. Derivative of the first part times the second part plus the first part times the derivative of the second. Doesn't matter which order you do it, as long as you do it both of them. Do both of these. Over here in the next step, I'm actually going to take the derivatives. Here, I'm just setting it up so you can see. This will be 6 sine x plus derivative of sine is cosine, so this will be 6x cosine. Please have all the inverse trig and trig derivatives memorized or on your formula sheet.
Just grab that PDFs.
Sure. Okay. Now we gotta do it again. y double prime. So take this solution and take a derivative again. Derivative sign, we just said. That part done. This is another quadrant rule. The derivative of the first plus the times it. Plus first times the derivative of the second piece. Derivative of 6x derivative of cosine. Negative sine. Right.
Just did it.
We have 6 cosine and 6 cosine. Right? That is 312 minus 6x sine. This will be the second root.
So they're just following the formula. It looks terrible. It looks stressful.
I think the answers is more stressful than anything.
I would try not to worry about the multiple choice. The multiple choice, polished answer. You guys aren't about polished, right?
As far as we can get. So stuff out there
Yeah.
that you do with it.
Their options are a perfect answer. So just work on it, not don't even give a crap about what's on there. Just do what you can do and I'm gonna grade your work. So watch yourself, you'll be all right.
So we could put an answer and then put or, and put another answer, or. Put these 5 answers. Oh,
It's just
can you factor out a 6 on that? Yeah.
good. That would be fun.
That's what writing jokes and answer books.
Like, please just give me 100.
I love it too. Look up some stupid jokes for the test. Right.
We're all actually learning how to calculate.
I've had people do that. They also like really nice picture. Instead of answering the question, they can also give you 2 points on it.
Dude, actually.
Wait.
I'm like, you know, not bad. 2 points.
I mean, they're gonna fail regardless, but I guess I'll give you something.
So if I answer the question and draw a picture, I actually be
Extra
understated.
credit, doc.
Just make sure you finish the test first, yeah.
Be consistent.
You're trying.
With your own.
I don't wanna see some like amazing drawing of you for 2 hours to do, and not do any math problems. So. You guys cool on 11?
Yes.
Go.
12 is when you begin doing the chain rule. At this point, everything after this is gonna involve chain rules. So let's start on 12. Find the derivative of the function. They call it Q. I guess that's fine. They used to have a Q though. I don't like what they used to do. First,
There's a difference between a lowercase q and a big Q.
man, I don't like C. Yeah, I struggle with that. Like when we're doing the angles, like capital C and lowercase c. Then I just put a bar on top, just C bar.
Just skip it to 80.
I guess I should stick with like Greek letters, but it should be. Anyway, I mean, that's traditional. Angles should be represented by Greek letters. But I mean, right now. Let's first prepare this question. Use Hebrew letters for levels of infinity. There's Hebrew letters. Most lines do have some.
So what you're saying, by the time I'm done with math, I'll know the Greek alphabet and the Hebrew alphabet. Solid.
Depends how far math.
Level of math you need to be for British college. No worries. Where's that?
Gotta die doing math.
You do 17 minutes.
Okay, so here we have the chain. Bring number down. Multiply with the derivative of the inside. Or the derivative. What is derivative of the inside?
You wanna put the R front?
Sure.
Negative 5R to 4. 17.
This will go on the bottom. This 2 will be on the bottom. Let's leave that half in front, which is kind of weird, but technically this is the derivative. This is algebra. So their answer is probably already pretty right. Doesn't look like this is that. You rationalize. Get their answer, I guess. So you will get -5 part of the 4th plus 17 times the square root over 2 times 17R minus R to the 5th.
R there.
Yeah, this one. Oh,
Just put the R.
gotta keep it now.
Something's working. It's working right.
distribute the square root.
Sir, this might be a stupid question.
What's up?
Will the calculator actually do that?
Do what?
Like you type that whole top part into the calculator, aside from the R parts. Would it actually do it correctly?
Unless you have something like fancy calculator.
I didn't think so.
What's 2 times 17? 32, 34. Okay. So that is topology you can make. I'll probably keep those. Factors a little nicer. I believe they stopped here. Right, so
So what was the final answer?
what it is a little bit more polished. I believe they have this one. What are they-
Oh, yeah, they do, they just didn't switch the.
So it's that one, the boss one, is the actual answer. in the-
That is correct. That was the option choice that they have. Yes.
Your definition of polished is because it's in the square root of the denominator.
Yeah, we're not supposed to have any screws on the bottom, so technically, we shouldn't stop there. Technically. But I'm not a anal about that kind of stuff.
We can't have a square root on the bottom. Why don't we just leave it up there as a negative 1/2?
Yeah, negative powers. It's another rule. Following all those rules will get you here. Any questions on 12? All right. Yeah, let's do it. This is a nasty chip. It likes the surface, so.
That's a positive. That's
That's
and
a
the outside.
positive quotient. Find the derivative of the function.
So this one's also.
What was the quotient rule? F over G derivative. 3 squared minus, which one goes first? GF prime? Or F?
It's like the product rule on top, it's the minus. Prime. I thought it was F prime times the regular G.
Yeah, so that's, which is fine.
Yeah.
Oh. Don't like pollution, so I avoided by forcing the product. My own thing.
Yeah, isn't the motion rule just the product rule on top instead of the minus sign?
Yeah, like I can force the bottom part to the top. And create a product rule. whenever I want. But doing that creates more changes. They can always avoid the quotient rule if I want to. Sometimes avoiding it creates a more complex problem. Like here, it would create a double chain, which might not be something you want to. Yeah, so bring down the three. Subtract 1 times the derivative of the inside. So that'll be 3 cosine x plus sine x squared. Quotient time. So derivative of the bottom. I'm sorry, derivative of the top times the bottom, right? So that would be 1 plus sine times cosine derivative minus cosine times 1 plus sine derivative. Derivative of cosine is going to do what? Negative sine. The 1 plus sine times negative sine minus cosine times derivative of 1 plus sine.
It's cosine. Cosine, yes.
Just cosine, right? 0 plus cosine.
Cosine squared.
Yeah, that's true. Do you agree that this is squared? That this would be the same, right? power square top and bottom. Distribute your negative sign, that'll give us negative sign of minus sine squared minus cosine squared over 1 plus sine squared. You agree that this times out will be just 4 of them. Right. Also, do you see that you can factor the negative? This sine squared plus cosine squared. We'll pop your recalc there. The OG Pythagorean theorem. From that would be like basically all the forms. Say, Big Daddy. Remember anything from recalc? Remember that. Yeah, so that'd be negative. Oh, that looks weird. You see how there's a times and a negative? That's strange. It's bothering. Check that out. Same thing. Magic. That's one of those, right? Same. Finally, we get negative 3 cosine squared over 1 plus sine. Give you some mathematics, polish a little more. What is cosine squared equal to?
We still have our answer to use here then.
I don't know what the answer choice is. I don't have it in front. Do they have something simpler, right? So you agree that cosine is 1 minus sine, remember? Because
Paper in front of me. I do remember it, kind of, but not like specifically.
okay, so this up that any substitution. Here. This factors into a difference of squares. You can see why we did this. That gives you one more solution. See that? So I will get space here. Negative 3 times 1 minus sine over 1 plus sine squared. That is as pretty as we can make it. Might be prettier than there. No. I don't know where this is.
Except when I get three, those next word.
Other than easy peasants. It's totally fine. If you guys are there, I won't be happy. I'm gonna box for base. But if you remember all your identities from pre-calc, you can see how you can go a little further. Right? In this case, we do not need to. And say we move on to this. Have any questions on 14? Listen. Implicit differentiation. Product by dy dx. So take the derivative with respect to x, because they said find dy dx. So dx of every single term. Derivative of x2. No big deal. With respect to x, so no implicit nonsense. Over here we have a product rule that will contain an implicit piece. So derivative first. Go ahead and show it in terms of primes. So it's a little more clear. We just need to remember that this is all respect to effect, right? So this is the product rule coming out of this. Okay. Brackets don't do anything. It's just for emphasis. Derivative of y cubed. Listen. Derivative of constants. 0. Now let's do derivatives of this product. Okay, so derivative of 3x squared is 6x times this y. Derivative of y is just 1 times dy dx because it's an implicit part. 3x squared dy dx. That part we already did. So the derivative is now done. Any questions on the derivative?
Guess that's on this.
So that is the derivative step. The answer they want is to solve for this. dy dx. So isolate these guys, and this is the right hand side. So we factor dy dx out of both of these terms. Divide this over there. You want to reduce that fraction?
Factor out of 3, right? We were denominators, so we cancel.
Factor of -3 from the top. We get x squared minus or plus 2xy. Factor of 3. Get x squared plus y squared. This is pretty enough for me. But what's in the inside anyway? Put the minus in front, just so that it looks better, not because it matters. Minus, you can do it on top, you can put it on bottom, put it in the front. You choose a spot, doesn't matter.
So better we factor out x.
Uh,
Can't cancel.
yeah, it doesn't cancel anything, so I think this is fine. This is good. I don't want it to cancel. Not gonna happen.
Try not to leave parentheses unless you can cancel out. We rule it down.
There's nothing wrong with that. It is a fine step to do. You could do that an additional step, nothing wrong with it. It's optional. better? No idea.
You were kind of wrong. We try to go farther. We have the right answer. We try to go farther than they wrong.
And you should follow the general rules. Like screw the bottom, negative powers. After that, I mean, canceling terms. I think those are fine steps. But trying to force extra stuff sometimes, yeah, you can run into mistakes. Scratching the car when you're polishing too much. Oh man, I have my ring on. Oh no. The boat buckle. Any question on this problem?
Okay, so how did you decide which gets the DYDX? Because that's what you have to take the derivatives of, or?
DYDX shows up whenever you're taking a derivative with respect to x. Whenever the derivatives don't match. So see how on this guy right here, ddx y cubed. This
That
is
doesn't
a-
have an X, it becomes the DYDX.
Yeah, so you do the normal rule. Here, see how I did 3y squared? That's the same as always. But because it wasn't an x, you tack this on.
Okay,
So over here, derivative of this is a 1, but you have to tack this on.
with the 3x squared DYDX, because that Y, it doesn't have a X, that's you have to tack on that DYDX also.
This one right here is this.
Oh, you moved, okay,
Yeah,
So that's
this
3x
one
squared.
is here. So derivative of y is 1 times dy dx. So we got this. This part, it just came down here. See it?
yes, the last one, the 8 DX is where I lost track. I know where you were pointing,
Got another?
I got it. Where'd that go? Okay, I got it.
Any other questions? So what's bothering?
What she was asking about, but when you explained it, it didn't help me understand it anyway.
What was it?
Yeah,
Which part?
trying to figure out where the DX goes.
Well, they stayed there the entire time until I factored it. So these pieces that had the dydx, I'm isolating on purpose. So these are right there, right?
Oh, that's not the part, it's higher up. Yeah. So it goes from there to the third line.
Right, so you're cool with this part being 0, right?
Yes, I get that,
Derivative of this is gonna be 3y squared.
I get that.
And then tack on the dy dx, because that's the implicit rule. Now, derivative of this is a product rule. So you're getting the derivative of this piece times the y plus the derivative of the y times the first piece. This is me setting it up for that's the product rule formula. Derivative of this is 6x times y. Right, derivative of this 6x times y. Derivative of this guy, well, derivative of the y is 1 times dy dx. So there's a dy dx times this piece. And that part just came down.
All right, that makes sense. Thank you.
The rest is okay. On a 17. 18 is same thing, but a little easier. 19 is the word problem. No, it's the 19. Yes. I think we did 20. We did something similar to 20. That's the 19. That one looks different. Okay. The water is falling on the surface, but in a circular area that is expanding at a rate of 7 millimeters squared per second. How fast is the radius of wetted area expanding with the radius of 150 millimeters? Guess the right question. So we have an area circle that is growing as it gets wet. So you guys picture like water droplets popping up, this spreading. Right? And the spread is measured in square units because this area. That makes sense. You want to know how fast the radius of the area is expanding. So you want us to find dr dt. We want us to find the rates of the radius. So dr dt. And giving us the point 152 millimeters. So that point in time, when the radius is hit 152 millimeters, what is the rate at that point? So first thing we need is the area formula for a circle. What is it? It's the area of a circle.
2 pi r squared.
2 pi or pi?
2 r, yeah, 2 pi. Pi r squared.
Pi. Okay. Before we get too far.
Yeah, space down.
Simple.
Doesn't it just circumference?
circumference, 2 pi
It's
r.
a pi r squared.
Confirmation makes me feel better. DADT. Implicitly, well, there's no real other variable, but it will be implicit. Because it's respect to time, right? We'll get 2 pi r dr dt. Right? So they wanted to solve for this. When r is this, and we're given the rate of the area, this is the ADT, so we actually have everything. The ADT, 7 millimeters squared per second. R is 152 millimeters. So clear at the end. Solve for DRDT. Okay, you gotta hook me up at this point. That makes sense. Yes. Divided by 152 millimeters and 2 pi. We get 7 millimeters squared divided by 2 pi 152 millimeters. One of those millimeters is cancelled. So my units will be in one dimension. Right. So calculator time. What is 7 divided by 2 pi 152?
Zero, zero, seven, three.
VR dt 0.0073 millimeters per second. So that is the rate of flow for the radius. Radius has hit 152 millimeters. What you got?
I can't check it until I turn on the whole thing, but it's one of the answer choices.
Oh, cool. Nice. Done over time, so we'll stop here. On Wednesday, I may be promoting, so message you guys ahead of time. I'll let you know. But we will go over the rest of these on Wednesday. Okay. I would like you to try them out and practice first. But
Leave your notebook up because I have a question.
so
On the very top one right there, under the, that's all we got the area of pi r squared underneath that, is setting up that second one. That DADT goes 2 pi r DRT, just how you said that.
So do the derivative of A with respect to time. Get rid of this with respect to time. So bring down the 2. Right. Subtract 1. Times DRDT because it's implicit. Basically what I'm doing is, what's up?
Took the derivative of
Yeah,
the area of the circle.
yeah, the derivative of both sides with respect to time. that gives me the derivative, the rate of change of the area over time.